Welcome to the deep dive. This is where we take the source material you've brought us, articles, research, maybe even internal documents, and we really plunge right in.
Yep. Our goal is basically to pull out those key nuggets, the aha moments, and boil it all down so it's easy to grasp and hopefully useful for you.
Think of it like cutting through all the noise. We're aiming to get you the crucial insights without you having to wade through everything yourself. Gives you a shortcut, really.
Absolutely. And for this deep dive, we're tackling something pretty common, but with a really fascinating twist: modernizing data architecture.
Right, but specifically through the lens of a major airline.
Exactly. Our source is an RFP response document that's a request for proposal response, laying out a proposed data solution specifically for JetBlue Airways.
Okay, so our mission today: unpack this technical document.
We want to figure out, what were the big data headaches JetBlue was facing? What exactly was the proposed fix the what?
And crucially, why did they pick certain tools or approaches? That why is key.
And then what's the payoff? What impact should this have on their business, their operations, and maybe most importantly for many listeners, on your experience as a JetBlue customer?
Yeah, there's some really cool stuff in here. I mean, how do you actually get real-time data off hundreds of planes while they're flying and pipe it into a data system?
Right. And once it's there, what happens when you start mixing that live operational data with, say, customer feedback? What new insights pop up? It's going to be interesting.
Let's dive into JetBlue's data journey.
Okay, first up, just setting the scene a bit based on the source material. JetBlue, obviously big player in aviation.
Yep, HQ in Long Island City, New York, founded back in '98, grown quite a bit since then.
Oh, yeah. The source mentions a fleet of over 270 aircraft now, mainly flying across North and South America.
And what jumps out from the document is their market position, right? They're known as low cost.
Right. But they've cleverly added these premium features you don't always expect. Things like free Wi-Fi in the air, live TV at your seat.
It's not just about the cheapest ticket, it's the experience. And the source document really emphasizes this, highlighting their digital focus.
Yeah, it talks about heavy investment in customer experience, wanting real-time analytics, getting personal with their marketing.
So it's clear they're not just thinking about planes and routes, they want to be a modern, data-savvy company.
And that focus, well, that's really the root of the data problems they needed to solve.
Which brings us right to the core challenge laid out in the RFP response. Basically, a classic problem for established companies: data stuck in silos.
Fragmented all over the place. And not just a few places.
No, the document lists a whole bunch of SaaS applications they use day to day. Big names.
Like Salesforce for CRM,
Yeah.
Zendesk for customer support stuff, Marketo doing marketing automation.
And Amadeus, which is like this massive system airlines use for bookings and flight operations. Super critical.
But here's the interesting twist for an airline. Those silos also included data coming directly off the planes, aircraft telemetry systems.
So streams of sensor readings, performance data, location, all that stuff, completely separate.
Exactly. You've got customer info here, booking data there, marketing results somewhere else, and the real-time plane data totally walled off.
And the source makes it clear their old ways of moving data around, the legacy ETL approaches, extract, transform, load, arc, they just weren't working anymore.
Yeah. The document calls out three main failings. One, they couldn't get data fast enough, no real-time capability, nightly batches weren't cutting it.
Right, not when you need to know what's happening now.
Two, integrating all these different systems was just massively complex. Building and patching together custom connections, a nightmare.
And that complexity, number three, meant huge maintenance overhead. Teams spending all their time just keeping the lights on, fixing broken data pipes,
Instead of actually using the data for something useful.
So the bottom line was pretty clear. They needed a central, automated way to bring all this data together.
From the SaaS apps and from the planes in the sky. Into one place, ready for quick analysis.
And that need, according to the document, led to some really specific goals for any new system.
Yep, the RFP response lists them out. They had to ingest marketing and customer data reliably from all those third-party APIs.
Okay.
They absolutely needed to stream that real-time sensor data from the aircraft.
And plane data, yeah.
Unify everything, different types, different sources, into a single fast warehouse for analytics.
Makes sense.
And crucially, make it possible for business teams to see this stuff on real-time dashboards. Let them act on insights immediately.
Okay, so you've got these two really different kinds of data streams, right? Scheduled pulls from business apps, and then this continuous flood from the planes.
Exactly. So it makes sense the solution proposed in the document isn't just one thing. They call it a scalable and future-proof hybrid ingestion solution.
Hybrid is the key word there, combining two approaches.
Right. API-based ELT extract, load, transform, a bit different from old ETL for the business systems, and then event-driven streaming for the plain data.
Because you need different tools for those different jobs.
Precisely. And the document names the main tools. Fivetran and Snowpipe for getting the data in. Snowflake as the central data warehouse.
And it's all running on Google Cloud Platform, GCP.
Okay, let's break down that hybrid model. Path A first.
Yeah.
The API-based ELT for the business systems.
So sources here are things like Salesforce, Amadeus, Marketo, Zendesk, Google Ads data.
Yep, and the tool pulling data from all those APIs is Fivetran.
Okay, Fivetran connects, pulls the data.
And loads it into Snowflake, which, again, is running on GCP.
Got it. And then the business users use Looker, the BI tool, to see dashboards and run reports on that data in Snowflake.
Now, the why Fivetran part is important here. The source says Fivetran has a ton of pre-built connectors for exactly these kinds of common SaaS tools.
Which means JetBlue's engineers don't have to build custom API connections from scratch for every single one, right? That sounds like a huge time saver.
Oh, massive. If you've ever dealt with integrating different software APIs, you know it can be incredibly painful. Constant updates, changes, breaking things. The source highlights Fivetran's no-code setup for many of these connectors. That just speeds everything up dramatically.
No code setup. Okay, that's a big deal for efficiency.
And maybe even more valuable, the document points out Fivetran automatically handles schema drift.
Schema drift.
Oh,
What's that in simple terms?
It's when the source system, like Salesforce, changes its data structure slightly. Maybe they add a new field or rename one.
Yeah.
Normally, that could break your data pipeline. You'd have to go in and manually fix your code. Fivetran, the source says, is designed to just adapt to those changes automatically. No frantic coding needed.
Wow, okay. That automatic adaptation sounds like it prevents a lot of headaches. So that's path A for the, let's call it, structured business data.
Right. Now well, the really cool part, I think path B, the file-based streaming for the aircraft IoT data.
The data coming off the planes in real time.
Exactly. Source is the aircraft sensors, sending data as JSON payloads. JSON is just a common way to structure data for sending online.
Okay. And where does that JSON data go first?
It hits Google Cloud PubSub. Think of PubSub as GCP's really fast, scalable messaging service, like a super efficient mail sorting center for data streams.
So it keys up the messages there.
Sort of, yeah. From PubSub, the data then lands as files in Google Cloud Storage, GCS. The GCS is basically a massive, durable storage bucket in the cloud. A landing zone.
Right, the staging area. But how does it get from just sitting in GCS into Snowflake where they can analyze it?
That's where Snowpipe enters the picture. The document specifies Snowpipe as the tool used here.
Okay.
It's designed specifically to automatically load data files from GCS into Snowflake pretty much as soon as they arrive. Continuous ingestion.
Automatically, so no one has to click a button or run a script.
Nope. Auto load, it just watches GCS. And the destination, again, is Snowflake, with Looker on top for the analytics.
So why Snowpipe specifically for this real-time stream?
The justification in the source focuses on it being serverless and scalable for this kind of continuous file-based flow.
Serverless meaning?
Meaning JetBlue doesn't have to worry about managing the servers running Snowpipe. GCP handles all the underlying infrastructure, scaling it up or down automatically based on the data volume. Big operational win.
Okay, less management overhead.
And that auto-load capability is crucial for the real-time aspect. It minimizes the delay. The source actually says it reduces ingestion latency down to just seconds.
Seconds. From a plane sensor to being queryable in the warehouse. That's impressive.
It really is compared to older batch methods. And the choice of GCP for PubSub and GCS.
Yeah, the source mentioned something specific there, didn't it? Beyond just fitting with Snowflake.
Right. Cost effectiveness, global reach, native integration, those are important. But the doc explicitly calls out aviation-grade resilience.
Aviation-grade resilience, that sounds serious.
It is. For an airline handling critical operational data in real time, you absolutely need infrastructure that's incredibly reliable, secure, and fault-tolerant. GCP apparently provides that level of stability needed for something this mission-critical.
That really hammers home the stakes involved. It's not just about marketing clicks. It's potentially about flight operations.
Precisely. Okay, so the data's flowing in. Let's talk about the heart of it all, Snowflake and Looker.
Snowflake, the central warehouse. What's special about it here?
A major strength highlighted in the source is how it handles both structured data like the neat rows and columns from Salesforce and that semi-structured JSON data from the planes, all in one system.
So they don't need separate databases. They can query the sensor data right alongside the customer data.
Exactly. Snowflake lets you use standard SQL to query that JSON directly. That's huge for breaking down those silos we talked about. The source also mentions Snowflake's performance, cost optimization.
And that separation of compute and storage thing. Can you unpack that a bit?
Sure, think of it like this. Traditionally, the engine that processes your queries, compute, and the place you store the data, storage, were often bundled. You need more processing power. You might have to buy more storage too, even if you didn't need it. Snowflake separates them. You can scale up your compute power when you have heavy analysis jobs running and scale it back down when you don't, paying only for what you use. Independently, you scale your storage based purely on how much data you have. It gives you enormous flexibility and helps control costs.
Got it. Like upgrading your car's engine without having to buy a bigger trunk at the same time. Makes sense. And Looker, how does that fit on top?
The Looker is the BI layer business intelligence. It's the window into Snowflake for the business users and analysts.
How they actually see the data and make charts and stuff.
Right. The source mentions Looker's embedded analytics capabilities, putting insights right into other tools people use. But it also stresses its strong governance features and row-level security.
Why are those so important?
Well, governance means everyone agrees on what metrics mean, like what counts as on time. Everyone uses the same definition. Row-level security is vital for controlling who sees what data.
Especially with sensitive customer or operational info.
Exactly. You can lock it down so specific teams only see the specific data rows they're allowed to see. Very granular control. And naturally, the source notes Looker integrates nicely with GCP, fitting the whole picture.
Okay, so we've got this impressive flow. Fivetran and Snowpipe bringing data in, Snowflake unifying it, Looker making it accessible, all on GCP. What's the actual business payoff? What benefits does JetBlue expect?
The source lists quite a few. The big one is real-time visibility, getting instant insights into things like customer feedback trends.
Like seeing if people are suddenly complaining about Wi-Fi on a specific route right now.
Exactly. Or seeing how a marketing campaign is doing minute by minute, not waiting till tomorrow, and having immediate access to aircraft diagnostic data. Huge.
That immediate access must drive operational efficiency too, right? Automating all those old, clunky data pipelines.
Definitely. That frees up the data teams. The source says it reduces that manual ETL grind, letting engineers focus on, finding actual insights or building predictive models, not just plumbing.
Less fixing pipes, more analyzing data.
And the document connects these faster data cycles directly to better business outcomes. Things like improved net promoter score, that customer loyalty metric.
Better customer retention because they can react faster to needs or problems.
Precisely. And then there's the future-looking part, which is really exciting. The source explicitly says this platform is built to be future-ready for AML applications.
Artificial intelligence and machine learning, what kind of things do they mention?
Two big ones. Predictive maintenance for the aircraft, using all that sensor data plus history to predict when a part might fail before it actually breaks.
Wow, that could prevent delays, maybe even safety issues. Huge implications.
Absolutely. And the other is customer churn prediction, using the combined data flight history, feedback, interactions to figure out which customers might be thinking of flying with someone else so JetBlue can try to keep them.
And that's where having all the data unified in Snowflake is critical, isn't it? You need the operational and the customer data together for those kinds of models.
You really do. This architecture gives them that foundation.
Looking ahead, the document also mentions scalability, right? Being ready for future growth.
Yeah, the modular design helps. If JetBlue adds a new marketing tool or wants to pull in data from, say, baggage systems, they can plug it into this framework more easily.
And Snowflake's independent scaling of compute and storage means they shouldn't hit performance walls as data explodes.
Right. Plus, being on GCP helps with things like security, managing who accesses what, and meeting all the strict compliance rules in aviation. It's all integrated.
Now, the document doesn't just paint a rosy picture, does it? It acknowledges risks.
Which is good, adds realism. They identify potential problems and how they'd handle them.
Like what? What if one of those third-party APIs, like Salesforce, goes down?
Good question. The mitigation mentioned is that Fivetran has built-in retry logic. It'll automatically keep trying to connect and resume pulling data once the source is back up. Plus, alerts go out so the team knows there was an interruption.
Okay, so it tries to handle temporary blips automatically. What about the plane data? what if the format of that JSON payload changes because engineers update the sensors?
Ah, that's where Snowflake's flexibility with semi-structured data comes in handy again. The source says Snowflake can generally handle variations in the JSON structure without breaking. It can adapt on read, essentially.
So minor changes don't require immediate schema changes in the database itself.
Okay.
And the last risk mentioned was latency, getting the data in fast enough.
Yeah, the delay between data being generated and being ready for analysis. And the mitigation there is Snowpipe's auto-ingestion. By automating it and running it serverlessly, they get that delay down to seconds for the aircraft data stream. Makes real time actually real.
Okay, so let's pull this back to you, the listener. Why does understanding JetBlue's data plumbing matter to you?
Well, if you fly JetBlue, even occasionally, this kind of investment is likely underpinning efforts to make your experience better. More relevant offers, maybe smoother operations.
Yeah, maybe faster rebooking if there's a disruption, because they have better real-time info. The stuff behind the curtain impacts the service you get.
Or maybe you're just interested in how big companies actually do digital transformation. This is a concrete example moving from messy old systems to a modern cloud setup.
It's a real-world case study.
Or perhaps you're fascinated by tech meeting industry, seeing how cloud tools are applied to the very specific demanding world of aviation. Does knowing this complexity change how you view your next flight?
It's definitely food for thought. So, to recap this deep dive, we've seen JetBlue moving strategically away from data silos.
Towards a modern dual-path architecture using Fivetran for business apps, Snowpipe for the real-time plane data.
All feeding into Snowflake as that unified warehouse running on GCP with Looker providing the insights.
The goal: real-time visibility across the board, customer experience, marketing, and critical flight operations.
And the source clearly points to future AI and ML uses like predictive maintenance and predicting customer churn.
Which leads to a final thought. Think about that constant stream of sensor data coming off hundreds of planes. We talked about maintenance prediction.
Right.
But what other maybe totally unexpected insights could emerge if you combine that live flight data in real time with, say, detailed weather patterns or air traffic control feeds, or even broader economic trends? Could having that truly instant combined view enable completely new services or efficiencies in the airline world that we just haven't even conceived of yet?
That's a fascinating question to leave things on. Thanks for joining us for this deep dive into JetBlue's data architecture transformation.